Most programming languages are procedural. Programs are lists of instructions that tell the computer what to do with the program's input. Functional programming simplifies problems into individual functions. Ideally, functions are pure, which means they don't have any state that affects the output. Functions can also be impure, which means they do retain state. Some programming languages are multi-paradigm, which allow you to write either procedural, object-oriented, or functional code, depending on the problem. Python is one of these languages. Here I have a procedural function that prints a multiplication table for all the numbers in range nums and all the factors in range factors. When it's run, it will look like this. We call the function by passing two ranges of numbers. To make this function reusable, I'll have it store the lines in this array instead of printing them. Then I'll just return this array. In order to have a pure function, I can lose the array by making this a generator. A generator function in Python has a yield statement, which gets the next item. Python makes the function usable like an iterator, so it only gets the next element when it's needed. In order to make the function lazily evaluate the next item, I use a generator expression to count and pair each number with its factor. Finally, I make this a higher order function so that it can be reused for division, subtraction, and more. A higher order function is a function that takes as an argument another function or returns one. Here I provide an optional argument for a custom operation and a symbol. Here I call our higher order function to generate an addition table from numbers 1 through 12. Because we're using a generator function, we can sequentially step through the values using the next function built into Python. Even though I have a huge range of numbers, getting the next value is instantaneous thanks to our lazy evaluation.